Math 1, parallel lines. So, find the slope of a line parallel to each given line. So remember, when we're talking about parallel lines, the basic idea is that they have the same slope. Okay? So, when our equations are in slope-intercept form, the number with the x, that's what our slope is. So a line parallel to that is going to have that same slope. So in question 1, our slope would be negative 3 over 5. Number 2, negative 5 halves. Number 3, negative 10 thirds. 4, negative 7 fifths. 5, negative 1 fourth. 6, negative 2. 7, 3. Okay, now 8 is a different situation. Okay, this is actually a vertical line. So it would be at x equals 1, we'd have this vertical line here. Okay, well, the slope is rise over run, so if I pick 2 points, let's say that's 1 and 2, my rise would be 1, but I'm not moving left or right, so it would be 1 over 0. Now, we can never divide by 0, so my slope would be undefined. Okay? Now, if it's a horizontal line would be like just y equals a number. Okay? Then if I pick 2 points, it would have a run of 1 and a rise of 0. That would just be 0. Okay? Alright, back to number 9. Our slope is 3, so the parallel line is 3. Negative 3 fourths would be for number 10. Now the rest of these equations are written in slope-intercept form. So in order to solve these ones, what we've got to do is we've got to turn it into slope-intercept form. Essentially the way we do that is we solve for y. So like number 12, I would just subtract x from both sides. That would give me y equals negative x plus 2. So my slope of negative 1 is what my parallel line would be. Okay, same with 14, we'd subtract an x. And we'd get y equals negative x minus 3. So my slope would be negative 1. Okay. Now, if I'm looking at one like 16, we still start off by subtracting the 9x. So we'd have negative 2y equals negative 9x minus 10. But then I'd have to divide everything by negative 2 to get it by itself. So I'd end up with y equals positive 9 halves, because negative over negative is positive, minus, well, plus, because negative divided by negative. 10 divided by 2 would be 5. So my slope is 9 halves. Okay, so that's what I do. So 11 subtract by 8x. We get negative 5y equals negative 8x minus 15. Divide everything by negative 5. We end up with y equals positive 8 fifths x plus 3. If I look at 13, we'd subtract 4x first. We get 5y equals negative 4x. Divide by 5. We get y equals negative 4 fifths x. So my slope in both those cases would match the same slope of my parallel line. Okay, for 15, we subtract a 3x, so we get 5y equals negative 3x plus 5, divide by 5, we get y equals negative 3 fifths x plus 1. So my slope would be the 3 fifths. Now, 17 through 20, these equations are just all over the place. Number 19 is already in slope-intercept form, so my slope would be a negative 1 there. Okay. For 18, I would times by negative 2 to everything. We'd end up with negative 2x minus 4 would equal y. So my slope would be negative 2x. On 20, we would add 6 to both sides to get 3x plus 6 equals 3y. Divide by 3. We'd get x plus 2 equals y. So my slope would be that 1. And 17, we just divide by 6 on everything. So I'd have 1 minus 8 over 6, which I could reduce to 4 over 3. So 1 minus 4 thirds x would equal y. So my slope would be negative 4 thirds. Alright. Now, when we're looking at the next group, these ones, we want to write a slope-intercept form of the equation. Okay? So, we need our slope and our y-intercept. Now, we're given a point, and we're given what it's parallel to. That parallel line gives us our slope, so I know it's y equals 4/5 x plus some number. Now, it didn't give us our y-intercept in this case, but it did give us an x value and a y value. So I can put in my number for my y value, put in my number for my x value, and then I could solve for b. 5 times 5 divided by 5 would be 1. 4 times negative 4 plus b would equal -4. Add 4 to both sides, we get 0 equals b. So my equation would be y equals 4/5 x plus 0. Or I could just leave that off like that. That's my answer for 21. So that's the process we're going to do on all of these. Okay? So for 22, I would change y to 5 equals 7/5, and then x would also be 5 plus b. Because I've already got my slope, so I just need my b. That would be 7. 5 equals 7 plus b. Subtract 7. Get -2 equals b. So my equation would be y equals 7/5 x minus 2. For 23, slope of -1, so y equals -1x. Then this one, 0, 1, that's actually on the y-axis, so that would be my y-intercept, so I'd go plus 1. For 24, this is an x-axis, so that wouldn't help us, but it'd be y equals 1/2 x. Then to find b, I'd go 0 for y, equals 1/2 times 4 for x, plus b. 1/2 times 4 is 2. Subtract 2 from both sides, and we'd get -2 equals b. So minus 2 here. So 25, my equation would be y equals x, so that's 1, so I'd go y, 1 equals x, -3 plus b, add 3, get 4 equals b, so that'd be plus 4. For 26, this is y equals -5, which that is a horizontal line right there. Okay, so then what I would do is it'd be y equals a y value of -3, so it'd be -3. It'd be a horizontal line at -3 would be my line. Alright, now 27 and 28. So 27, y equals x, and then I gotta find b, which is not -4. So 0 for y, -1 for x, plus b, add 1, get 1 equals b, so plus 1. And then 28, x equals 0, that's a vertical line. Okay, so my x value would be -3, so it would be x equals -3. Okay, 2 more. So slope of -2/5, so y equals -2/5 x. Then I would go y equals, change the y to -2 from my point. -2/5 times -5 plus b. 5's cancel, negatives cancel. 2 plus b equals -2, subtract 2. We get -4 equals b. So minus 4. Okay, 1 and 1, so I'd go 1 equals 1 plus b. Subtract 1, I have 0 equals b. So I'd have y equals x. Plus 0 if I really wanted to. And there's those ones. Now in these ones it wants us to draw a parallel line to that given line. So the easiest thing to do is simply find its slope. So pick 2 points. There's a point, up 2 to the right 1. So then I pick a point, and then I go up 2 to the right 1, up 2 to the right 1, and there's my parallel line, if I could actually draw a straight line. For 32, pick a point right there, then right here, so down 1 to the right 5. So pick a point, down 1 to the right 5, or up 1 to the left 5. There's my parallel line. Okay, it's a horizontal line, so I just make a horizontal line anywhere I want. As long as I have the same slope, that's all we need. Okay, so here's a point. Where's another good point? Do we see one? Looks like right there. So I go up 8 to the right 5. So my slope is 8 over 5. So I pick a point, maybe right here, right there, up 8 and over 5. And there would be my parallel line. 35, picking those points. Here's a point, here's a point, down 3 to the right 5, pick a point, down 3 to the right 5, there's my parallel line. Vertical, just pick a vertical line and draw it. Those ones are easy, aren't they? Okay, 37, pick a point, up 2 to the right 1, pick a point, up 2 to the right 1, there's a parallel line. And finally, pick a point, pick a second point, we go down all this way, so let's just move here, we go down into the right one, there's my vertical line. Alright, now the back page is just finding the distance between points. Two ways we can do it. Pythagorean Theorem, which is the way I prefer. You just draw a triangle, a right triangle, make it 1, 2, 3, 4, 5 here, 1, 2, 3, 4, 5 here, and then go 5 squared plus 5 squared, because those are my legs, equals c squared. So 25 plus 25 equals c squared. 50 equals c squared. Take the square root of 50, and we get c about 7.07. Okay, so that's one way we could do it. Works for either method. So here, down 2 to the right 1. Okay, so I'd go 2 squared plus 1 squared equals c squared. 4 plus 1 gives us 5. Take the square root of both sides, and the square root of 5 would give us about 2.24. Okay, the other way is using the Pythagorean theorem, which is, or the distance formula, which is based off the Pythagorean theorem, but it's just using the points instead. It looks like this. So we take that point, which is negative 1, 5, and 4, 1. We assign this to be our y, x2 and y2, and this to be our x1, y1. And then I plug it in, so I go the square root of y2, 5 minus y1, 1 squared, plus x2, negative 1 minus x1, 4 squared. So I get 4 squared plus negative 5 squared. So that'd be 16 plus 25, which would be 41. So we'd get the square root of 41, which is, put it in my calculator, it's about 6.4. That was a 6. Okay, 41, we do the same thing. Okay, we don't want to do that, do we? So it'd be negative 5, 0, and negative 2, 3. So I go the square root of my y's, so 0 minus 3 squared, plus my x's, negative 5 minus negative 2 squared, be plus, so negative 3 squared, plus negative 3 squared. So 9 plus 9, so be 18, square root of that, because it's all under the radical. So 18 would give me about 4.24. Okay, now on the rest of them, the Pythagorean theorem is a little bit harder to use. So we'd probably most likely want to use the distance formula. So I'd go my y, 3, minus my other y, 8, squared, plus my x, negative 7, minus my other x, negative 6, squared. Notice that if I choose this one first for y, I choose it also first for x. Okay, so that would be negative 5 squared plus negative 1 squared, so 25 plus 1, so it would be the square root of 26, which would be about 5.1. It's 5.099, but we'll just call that 5.1. Okay, so 45, do the same thing, square root of 6 minus 5 squared plus negative 7 minus negative 3 squared, be plus, so we'd have negative 4 squared plus 1 squared. 1 plus 16 would give us 17, square root of 17. Give us about 4.1. Okay, so 47, 2 minus negative 5 squared plus 8 minus 1 squared, so we'd get 7 squared plus 7 squared, so 49 plus 49, which would give us the square root of 98, which would equal about 9.899, so about 9.9, pretty close to 10. Okay, you could try to use the Pythagorean theorem for it. I'll show you on the last two. Let's do one more. So, square root of 1 minus 2 squared plus negative 8 minus 1 squared, so that'd be negative 9 squared. 1 minus 2 would be negative 1 squared, so we'd have 1 plus 81, so it would be the square root of 82. Should be about 9.1. Okay. The other way you could do it is realizing that these points would form a triangle. We could kind of do this same process but separated. We could say, well, this would be like 7, 1. This would be like negative 2, 1. Okay, which actually would be a horizontal line, wouldn't it? Because they have the same y values. So this would have a 0 for that length. 7 minus a negative 2 would give us 9 for that length. So it would be 9 squared plus 0 squared equals c squared. So 9 squared equals c squared. Take the square root, and we'd have 9 equals c. Okay, let's try 48. Would hopefully work a little better. So, if I think about this graphically, to have this point 8, negative 1, and 4, negative 6. So if I think of that as a fraction, or as a triangle, negative 1 minus negative 6, that'd be like plus, give me a distance there of 5. 8 minus 4, give me a distance of 4. So then I go 4 squared plus 5 squared equals c squared. 16 plus 25 would equal c squared. Be 41 equals c squared. Take the square root. I think we did the square root of 41 once. We get 6.4 for our answer, which is essentially doing the same thing that you did in the distance formula. And there we go.